standard form is this. Standard form looks like this. AX plus BY equals C. AX plus BY equals C. For example, if I had 2x minus 6y equals 12. That's in standard form. That's an example of what standard form would look like. Yes?
Why is it called standard form if the slope-intercept form is used more?
This is more used for higher degree polynomials. There you go. Okay, so this is called standard form. It's where your x's and y's are on the same side of the equal sign. X's and y's are on the same side of the equal sign. My x's and y's are on the same side of the equal sign. And any numbers are on the other side. So what I want you to notice is these are on the same side. Any number that's by themselves is on the other side. That's how I know it's in standard form. Now, a lot of times you are going to be given equations that are in standard form and you're going to be asked to graph them. Okay? And the easiest way to graph things that are in standard form is to find your x and y intercepts. And so that's what we're going to learn how to do first. How do we find x and y intercepts? Let me write that down. How to find x and y intercepts. We're going to set up a chart. If you put your pass right, that'd be great. We're going to set up a chart real quick. We are going to make an xy, and we're going to do a 0 here and a 0 here, just like that. How to find x and y intercepts. How do we do it? We set up a chart with a 0 in the x and a 0 in the y. What this is going to tell us is if we plug in 0 in for x and we're trying to figure out what the y value, that will let us know what the y-intercept is. If I plug 0 in for y and I figure out what x is, that will let me know what the x-intercept is. When I'm figuring out this blank number, the number I don't know, that's going to tell me what the y-intercept is because the x is 0 and I don't know what the y is. When I plug in 0 in for y, that will let me know what the x-intercept is. I'll show you what I mean when I look at the problem I created above. Earlier, I had gave you this problem. It was 2x minus 6y equals 12. You remember that problem? If I have something in standard form, the first thing I should do is find an intercept. I'm going to plug in x is 0. I'm going to use this for this problem. Look at what happens here. I'm going to plug in 2 times, instead of x, I'm going to write 0. 2 times 0 minus 6y equals 12. And let's just solve that. Now, I did this here. I wrote it out for you, but what you're going to do, since most of you know what this is, what is 2 times 0? 0. See, I could tell all of you knew that. It's going to go away. 2 times any number 0 makes it disappear. So guess what we have? We have this problem here. Negative 6y equals 12. And so a lot of you are going to do this part in your head and know that you have a negative 6y equals 12. We just have to figure out what y has to be when I have negative 6 times some y equals 12. You're going to divide by negative 6, divide by negative 6, and I hope you know what 12 divided by negative 6 is. What is it? I'm going to put y equals negative 2 right there, because that's what it is. So when x is 0, the y is equal to negative 2. That is our y-intercept. He's not here. Thank you. If we found our y-intercept, we also have to find our x-intercept. And what we're going to do for that, we start over. We take our 2x minus 6y equals 12. And this time we're going to plug in 0 in for y. Do you want me to write out negative 6 times 0, or do you know what that's going to be? So here's what I do. In my mind, when I plug in 0 in for y, I just go, oh, 0 is going to be there. That's going to go away to 0. And I just kind of cross it off. And I do that in my head. If you need to, you'll write it down or do it in your head. It's up to you. And you have this one little problem left. You have the 2x equals 12. And you need to figure out what x is going to be. Do you know what it is? What is it? And you have 2 points that you can graph now. The 2 points that you can graph, 0, negative 2, and 6, 0. All we have to do to graph this is label which one's which. Let's label that this is our x, this is our y. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And 6 positives, 6 negatives. 1, 2 positives, 2 negatives. I'm going to go and zoom in here so you can see what I'm doing for the graph. If my x is 0, my y is negative 2. This is the hardest part, is knowing where you're going to go. 0, negative 2. Do I go up, down, left, or right? Do we all agree I'm going to go down? Because the x, I go 0 left and 0 right. The y, I go down, negative 2. It makes it a lot easier when you write x and y every single time. That's what I was trying to tell some of you last time when we were graphing. It should make your life easier. Now, I graphed the y-intercept, 0, negative 2. Now I'm going to graph the x-intercept, which is, which way do I go from the origin? The x is 6, the y is 0, and I have 2 dots. One on the x-axis, one on the y-axis. If you have your 2 dots, you can connect your lines with your ruler, and you have your graph. So in standard form, what's really the whole goal of standard form is that we use an x-intercept and a y-intercept to graph them. And so we have to be able to find an x-intercept and a y-intercept for our functions. Make sense? Okay, now let's make this a little bit harder. Sometimes when you have to do this, sometimes your x and y intercepts will be a fraction, so don't freak out if that happens. I'm going to give you an example like number 7. Here's your equation for number 7. Let me zoom in just a little bit more. 3x plus y equals negative 2. The directions will say graph using x and y intercepts. Graph using x and y intercepts. That's what the directions will say on your worksheet. 3x plus y equals negative 2. So that means we have to do an x, y, and if I want to find their intercepts, this is how I want you to set it up every time. You're going to make this little t-chart. You have an x and a y. I want a 0 for the x, and I want a 0 for the y. Matter of fact, when you look at your worksheet, I actually put an x, y for your first 4 problems so that you would have that same table in your problem. And now, if x is 0, what is y? Let me see if I can do that. If this 3 times 0 plus y equals negative 2. See how I just put my finger over it? That's kind of how I see it. Do you know what y has to be for that? Tristan sees it. Because 3 times 0 makes this go away. And you only have to solve for figure out what y is. Most of the time, it will come out nice whole numbers. Sometimes it doesn't, though. That's why I wanted to show you number 7. Because what happens when I plug in 0 for y? Now let's cover up this one. When 0 goes in for y, 3x plus 0 equals negative 2. The 0 goes away. 3x plus nothing just means 3x. Equals negative 2. Do I have the x by itself yet? What's next to the x? What do I have to do with that 3? Does 3 go in evenly into the 2? So here's what I want you to do. If you cannot put 3 into 2, 3 does not go into 2, I want you to leave that as your x coordinate, negative 2/3. I think the hardest part for students is what's next to the x. You're getting rid of the 3. Divide by 3, divide by 3. And if it doesn't go in evenly and it doesn't reduce, just leave that as your answer. The x equals negative 2/3. Now you got to graph it. I only need 2 spots every single spot. 1, 2, 1, 2, 1, 2, 1, 2. This is my x-axis. This is my y-axis. 1, 2, negative 1, negative 2. 1, 2, negative 1, negative 2. I think this point is easy. 0, negative 2. So I go where? From here down 2 units. I like it. But this one is the one that might get you confused. So what does this mean? I'm going negative 2/3 of the way of a whole unit. Did I get to negative 1 yet for negative 2/3? No, it's less than 1. So I'm going towards negative 1, but I only go 2/3 of the way. It is okay to estimate where negative 2/3 is. I'm going to go 2/3 of the way. And if you go, that's about half. Well, it's so close, we won't be able to tell. When you have your x-intercept and your y-intercept, you'll be able to take your ruler and graph it. And that's as much work as I want you to do. Ray?
Can we label the x-axis as fractions?
You could, but on most of the worksheet that I have, the graph paper is going to have numbers already there for you.
Oh.
It's going to be numbered 1 through 5 and 1 through negative 1 through negative 5 and so on, which is why I'm pointing that out to you. So does that make sense to you? Do not freak out if one of your intercepts is a fraction. 3 of them will have a fraction that you will have to graph. If you want to know which ones will have them, I'm going to have you write them down just so you're not surprised. 7, 8, and 10. 7, and I'll put 8 and 10 right underneath the 7 so you guys know which ones will have at least one fraction in the intercept. Okay? To give you a clue. Let's do horizontal and vertical. So let me slide that up a little bit. If I have a horizontal line, looks like this. Horizontal lines are always y equals some number. I'll put some number. It could be a positive number or a negative number. Doesn't matter. It's going to make a horizontal line. Vertical lines go like this, up and down. A vertical line is always x equals some number. The slope would be undefined. Does not mean that we cannot graph a vertical line. Is it a function? Nope, it's not a function. Is there a slope for it? Nope, it's not a slope. Can we still graph it? Yes, we can still graph it. It's an x equals problem. So you're going to have a couple of questions that are going to ask you to graph like x equals 5. If you have x equals 5, you make a vertical line at x equals 5. If you have y equals 5, you're going to make a horizontal line at y equals 5. Let me give you one example. If I were to ask you to graph x equals 2, then your graph paper, you would go over on your x-axis to 1, 2. This is where x is equal to 2, and you would make a vertical line at x equals 2. Just so you have that as an example. I could show you one for horizontal, but if you understand this, you should be able to do the horizontal one as well. The last thing I want to cover is how to put something into standard form. Let me recenter my screen. How to put an equation into standard form. I'm going to zoom out just a squeeze because I need to write something over here. The first thing I want you to try to do, distribute if possible. Not all the time are you going to have to distribute, but sometimes you're going to have to distribute. Second thing you're going to need to do is to clear fractions. By multiplying by the common denominator. Common denominator. It's going to go a little bit past right there. Sorry for those of you who don't like that, but it did. Distribute clear fractions by multiplying by the common denominator. And lastly, get x's and y's on the same, thank you, side. Get x's and y's on the same side and numbers on the other. Distribute clear fractions by multiplying by the common denominator. And then lastly, get x's and y's on the same side and the numbers on the other. This will be like number 20. So I'll put a little 20 right there in a bubble for you. Number 20 says y minus 1 equals negative 1/2 parenthesis x minus 4. Y minus 1 equals negative 1/2 parenthesis x minus 4 end of parenthesis. This is what we covered last time. This is in point slope form. And what we're going to do is put this into standard form. So how do I put it in standard form? The first thing, if you can distribute, is there anything to distribute here?
Yes.
Let's distribute this negative 1/2. Do I just put the negative 1/2 to the x? Is there something else that I have to distribute that negative 1/2 to? So I'm going to leave this alone. This makes negative 1/2 x. What does that negative 1/2 of negative 4 make? What's a negative times a negative? Let's do that part first. Positive. And what's half of 4? Okay. We've done step 1. We've distributed. Distribute clear fractions. Step 2. Clear fractions by multiplying by the common denominator. Do you see a common denominator? Here's the only denominator. What does that mean? That means I need to multiply everything by 2. When I see this 2, I'm going to take this whole thing. I put brackets around the whole thing, and I'm going to put a 2 out front. I'm going to multiply everything by 2. And I can do this because there's an equation here. Because there's an equal sign. I could do one thing to one side and one thing to the other, and it's still equal. So I'm going to take this 2, and I'm going to distribute the 2 to the y, to the negative 1. I'm going to multiply it here, and I'm going to multiply it there. So let's see if we can do this together. 2 times y is, say it out loud, please. Thank you. 2 times negative 1 is, say it out loud, please. Good. Equal sign, equal sign. 2 times negative 1/2. Negative 1/2 of 2 is? Okay, I'm going to put a negative dotted 1, x, so you know what it is. Because you don't really need the 1 there. I just put it invisible so you could see it. 2 times the positive 2 is? Good. All right. We have now done, we've distributed, we've cleared fractions by multiplying by a common denominator. Now number 3, get x's and y's on the same side and the numbers on the other. My x's are on this side of the equal sign, and my y's are on this side. So I'm going to move one or the other. Which one should I move? What's the opposite of subtracting x?
Adding.
Yes, let's do that. And it's supposed to be x's first, then y's. Like if I go way back up here, ax plus by equals the number. X is first, then the y's, then any numbers on the other side. So let's do that. X plus 2y. Because they're not like terms. Can I move the 2 over right now? Would you be okay if I did the opposite of minusing 2? What's the opposite of minusing 2? So 2 minus 2 goes away. Equals. 4 plus 2 is? And this is in standard form. This is something that you could find the x-intercept and the y-intercept and graph it. Logan has a question.
Do you have to, does it matter if the x's and the y are flipped?
Like on this side over here, like 6 equals?
Will that, or could it be 2y plus x?
You could be, but the way our textbook will write it and the way a scholar would write it will match this format up here. X's first, then y's equals some number. Okay, so I'm going to do the same thing. Other questions? We'll end our